Hello everyone, this is Mr. Rowe. I wanted to make a little video that talks you through problems 1 through 8 and 10 on page 457. This is your assignment for the 13th of March or the 14th of March, depending on when you have me. So we'll begin with number 1. What is the relationship between the pH and the H plus concentration? So we know that pH and H plus share a logarithmic relationship. A 1 point increase in pH is a 10-fold decrease in the H plus concentration. That means that you divide by 10 for every you divide the concentration by 10 for every increase in your pH. The higher the pH, the more basic, the lower the hydrogen cation concentration. But the lower the pH, the higher the hydrogen cation concentration, the more acidic it is. Which leads on to the next problem. Number 2, how is the H plus concentration related to the OH minus concentration in a solution? So now we're comparing the hydrogen cation concentration with the hydroxide anion concentration. Arrhenius tells us that acids dissolve into H plus and bases dissolve into OH minus. So they are inversely proportional to each other. That just means when one increases, the other decreases. Yeah, very simple, very simple. So now we get to the math. Number 3, what pH would you expect for solutions with the concentrations given here? So, oh, sorry. For part A, our concentration is 1 times 10 to negative 4. I don't know why the whiteboard decided to make those subscripts. I have no way of making them superscripts, so it should be 10 to the negative 4, which should be an exponent. I have on sticky notes the 3 equations that we'll be working with up here. Right now, it's just simple plug and chug. So pH is equal to negative log of 1.0 times 10 to the negative 4. And when you put that in your calculator, it should just give you 4. For part B, our concentration is negative log 1.0. Oh, sorry, hydrogen cation concentration is 1.0 times 10 to the negative 12. pH, here, pH is equal to negative log 1.0 times 10 to the negative 12. When you plug that into your calculator, you should get 12. Here's where it gets a little trickier. Now, part C gives us the hydroxide anion concentration, which is 1.0 times 10 to the negative 8. So all you need to do, so it's not as simple as plugging it into the equation because the equation normally uses hydrogen cation concentrations because these are acids. But if it's a base, it won't be given in hydrogen cation concentration. It'll be given in hydroxide anion concentration. So we're going to be using this third equation right here, the one on the right. Um, the third sticky note on the right. So first we need to solve for H plus. And we do that by doing 10 to the negative 14. I always highly, highly recommend you include parentheses in your calculator so that there's no confusion. Divided by the hydroxide anion concentration, which is 10 to the negative 8. So where did I get this 10 to the negative 14 from? That is from your equation. That is a given. That's a constant from your equation. Technically, it's called the water dissociation constant. And then the 10 to the negative 8, that is our concentration of hydroxide anion. When you solve it out, it's going to give you 10 to the negative 6 molar. But now that you have the hydrogen cation concentration, we are free to plug in the answer, to plug in the concentration. 10 to the negative 6. And that should just give you a pH of 6. Okay, so our answers for part A is 4, answer for part B is 12, answer for part C is 6. Notice how even though I typed it up, I still showed my work. Number 4, determine the pH for solutions with the H plus concentrations given here. This time, wait, it's the same process. pH is equal to the negative log of 0.0014. When you put that into your calculator, that should give you 2.85. So that is the pH resulting from that. For part B, pH is equal to the negative log of 6.0 times 10 to the negative 8. And that should give you 7.22. That's your pH. For part C, same thing. It's just plug and chug. Negative log of 4.2 times 10 to the negative 11. When you plug that in, you should get 10.38. And then for part D, again, all you need to do is pH is equal to negative log of 1.5 times 10 to the negative 1. But if we remember our scientific notation, 1.5 times 10 to negative 1 is just equal to 0.15. And that should give us 0.82. So these are the answers for parts A through D for number 4. And for number 5, which of the solutions in problem 4 are acids, which are bases? So let's look at A. Remember, anything that is below a 7 is an acid. Anything that is above a pH of 7 is a base. So over here, we've got anything under than a 7, 2.85 and 0.82. So we know that parts A and D are both acids because it's below 7, while parts B and C are both bases because they are above 7, a pH of 7. You'll notice that part B is at 7.22, so it's only barely above 7. Even though it's close to being neutral, that 0.22 makes all the difference, so it's still considered a weak base. A weak base, but a base nonetheless. Okay, so those problems 1 through 5. Let's continue. Number 6, what is the H plus concentration that you would expect that you would Oh yeah, well, what hydrogen cation concentration would you expect for the following solutions? So pH equals 9. So this time we're using the middle equation, this middle um this middle um sticky note equation at the top. So now what we're doing is sorry, um H plus is equal to 10 to the -9. And actually, when you plug it in your calculator, this is the same number. So 10 to -9 molarity. This time you do need to put the unit because now we're working with molarity. Now for part B, we are working again H plus. Now that's equal to 10 to the -7.3. When you plug this into the calculator, this time it's actually going to give you a number like 5.01 times 10 to the -8 molar. What a lot of students were doing that I noticed earlier was that they would put times 10 to the -7.3. However, that's not solving the problem. You plug it in, but you didn't solve it. Um, it works with part A because it's just times 10 to -9. But since we're working with -7.3, once we add in the decimal, then you should absolutely solve it. So your answer will be 5.01 times 10 to -8. Don't just leave it at times 10 to the -7.3. That was an issue I saw a lot yesterday um in some classes. Same thing with part C, times 10 to the -2.9, and that is equal to, your calculator will probably give it to you in scientific notation or in standard notation. It should give you a concentration of about 0.00126 molar. In scientific notation, this would be 1.26 times 10 to the -3rd molar. And as for part D, when we get H plus, it equals 10 to the -10.2. And that's going to be equal to about 6.31 times 10 to the -11 molar. So it's a very, very, very small concentration. Okay, we're almost done. Number 7, what is the pH of a 2.5 molar hydrochloric acid solution? So hydrochloric acid is an acid. How can I tell this is an acid? Because it has one hydrogen. That tells me it's an acid, a strong one at that. So all you need, if we're finding a pH, it's very easy for us. All we need to do is put negative log of 2.5, and this is going to be a negative number. So, which will give us negative 0.398. So around negative 0.4. That means it's extremely acidic. Yes, a negative pH is possible. We don't normally see it, but it is possible. Number 8. What is the pH of a 0.256 molar sodium hydroxide solution? This time, however, we are given a sodium hydroxide. I know that this is a base. How can I know this is a base? I can tell this is a base because of the OH. That OH makes all the difference. So we need to do that step of solving for H plus first. So from the equation above, we know 10 to the negative 14 divided by our hydroxide anion concentration, which is 0.256. That should give us about 3.9 times 10 to the negative 14 molar of hydrogen cation in solution. We're not quite done yet. We need to take that number we just solved for, and now we can plug it into our pH equation. So pH equals the negative log of 3.9 times 10 to the negative 14. When you plug that in, you get a 13.4. So that's extremely basic. It's a very strong base. Okay. As I mentioned earlier, how do I know sodium hydroxide is a base? How do I know that I need to do this additional step before I do the pH? If it has the OH in the formula, NaOH, that is a base. If it's a base, it's going to dissolve into hydroxide anion, not hydrogen cation, which is why we need to do this initial step first. Number 7, in number 7, we can just plug it in because hydrochloric acid is an acid. I know it's an acid just by looking at it because it's an H. Number 10, normal rain is not pure water. It contains carbon dioxide, CO2, which reacts with water to make a solution of carbonic acid, H2CO3, aqueous. The pH of rainwater is 5.6. Is carbonic acid an acid, a base, or neither? Explain. Well, other than the fact that the name gives it away, carbonic acid, I don't know why they did that. The pH of rainwater is 5.6. Anything below a 7 is acidic. So we're going to put H2CO3. Remember, these should be subscripts, but on the Zoom whiteboard, there's no way for me to write subscripts. What happened here? Okay. Is acidic because it has a pH of 5.6, which is less than 7. pH below 7 is an acidic solution. Okay, I think most everyone understands that one. Part B, write a chemical equation showing the reaction of CO2 and H2O to make a solution of carbonic acid. Be sure to include the phases of the reactants and products. So that one's very simple. So our reactants are CO2. Remember, the 2 should be a subscript. This is a gas because it's in the atmosphere. And it is reacting with H2O as a liquid. Remember our arrow to form H2CO3, carbonic acid, and an acid is always aqueous, so it's dissolved in the water. Okay. So that's what they mean when they say include the phases of the reactants and products. It's everything in these parentheses. Carbon dioxide gas reacts with liquid water to form carbonic acid, which is aqueous in solution. Okay. Those were problems 1 through 8 and 10 on page 457 of your textbook. This is your assignment for the week of March 11 through 14. My second and third period do this on the 13th. And my fourth, fifth, and sixth period do this on the 14th. You can refer to this video to help you out. Remember, this is to turn in for a grade. And that's it. Please let me know if there's anything I can help you out with. But let's also remember to pay attention in class, okay? I shouldn't have to be doing these videos because we need to be paying attention in class. Okay. Thank you, everyone.